Here's a weird question that sounds ridiculous, but isn't. When you charge your phone from 0 to 100%, does it get heavier? Like physically heavier, more mass, because you just pumped energy into it, right? So where does that energy go? Does it just float around inside the battery like some invisible ghost? Or does it actually add weight? And before you say, obviously not, think about it for a second. You're storing something. Energy is a real thing. It powers your screen, runs your apps, keeps your phone alive. So if that energy is real enough to do work, shouldn't it weigh something? This matters because it touches on one of the strangest ideas in physics, the idea that energy and mass are basically the same thing, that storing energy in an object actually makes that object heavier, which sounds like science fiction, but it's not. It's just incredibly, stupidly small. So, let's follow a battery. We'll call him Steve. Steve is a lithium-ion battery sitting inside your phone. Right now, Steve is completely dead, 0%, drained, useless. When Steve is empty, he's basically just a container full of lithium ions hanging out at one end doing nothing. Now, you plug in your phone. Electricity flows in. And here's what happens. Those lithium ions inside Steve start moving. They migrate from one side of the battery to the other. They're not disappearing, they're not being created, they're just rearranging themselves, moving from the positive electrode to the negative electrode, getting into position. And when they settle into their new spots, they're holding potential energy, like a compressed spring or a book lifted onto a high shelf. The ions haven't changed. Steve hasn't gained any new atoms, but he's now storing energy, ready to release it when you need it. But here's the weird part. That stored energy has mass, actual physical mass, because of a little equation you might have heard of. E equals mc squared. Energy equals mass times the speed of light squared, which means energy and mass are interchangeable. If you add energy to something, you add mass. Tiny, invisible, practically impossible to measure mass, but real mass. So when Steve charges up, he gets heavier. Not because you're adding atoms, not because electrons are piling up inside him, but because the energy he's storing has its own weight. Now here's the question. How much heavier? Because if this is real, there should be a number, right? So let's do the math. A typical phone battery stores about 10 watt-hours of energy when fully charged. That's roughly 36,000 joules. Plug that into E equals mc squared, and you get a mass increase of about 1/trillionth of a gram. 1/trillionth. That's 10 to the power of -12 grams. To put that in perspective, a single bacterium weighs about 1/trillionth of a gram. So charging your phone adds the mass equivalent of one bacterium. Maybe. Your bathroom scale can't detect that. A scientific scale can't detect that. Even the most sensitive instruments in the world would struggle, because it's absurdly, comically small. Your phone gains more weight from a single skin cell falling onto it than from a full charge. But it's still there, technically, theoretically, in the same way that a wound-up spring weighs more than a relaxed spring, or a lifted book weighs more than one sitting on the floor. The energy is real. The mass is real. It's just invisible. Now, this is where it gets even stranger. When you use your phone, you're discharging Steve. The ions move back, the energy releases, and that tiny, microscopic amount of mass disappears. It converts back into energy, into light from your screen, heat from your processor, sound from your speaker. The mass becomes motion, radiation, warmth. It leaves the phone entirely. So in a way, your phone is constantly losing and gaining mass as you use it. Charging adds a bacterium's worth of weight. Using it removes that weight, over and over, invisibly, unmeasurably, but real. And here's the kicker. This doesn't just apply to batteries. It applies to everything. A compressed spring weighs more than a loose spring. A hot cup of coffee weighs more than a cold one because heat is energy and energy has mass. A book on a high shelf weighs more than the same book on the floor because gravitational potential energy has mass. The universe is full of these invisible weight changes. We just never notice because they're so stupidly, impossibly small, but they're there, hiding in plain sight, making reality just a little bit weirder than it seems. So, is your phone heavier when it's fully charged? Yes, absolutely, by about 1/1,000,000th of a gram, which is technically more than zero, but practically nothing. You'd have better luck weighing a thought. And that's the beautiful, frustrating truth about physics. The answer is yes, but also no. Yes, because the math says so. No, because it doesn't matter. The energy is real, the mass is real, but the difference is so microscopic that it might as well not exist. So next time you charge your phone, just know you're making it heavier by the weight of a single bacterium, which is technically correct, the best kind of correct.